Hello, everybody, and welcome to Principles of Economics. I'm hoping this is working, and it appears it is. Great. For those of you that could not be here tonight, hopefully you'll find this useful. What I'm going to do is I'm going to walk through some of the problems that we're going to do on the Week 6 exam, right? And we're going to cover a number of different topics. We will discuss a lot of the macroeconomic goals that we discussed in class last night, including gross domestic product, inflation, unemployment, and things like that. So let's take a look at problem 1, okay? This may take a moment for the computer to adjust it. So let me read the problem if you're having trouble seeing it, okay? The first one says, the size of the labor force in a community is 500, okay? And 400 of these folks are gainfully employed. Now, in this community, 100 people over the age of 16 do not have a job and are not looking for work. In addition, 200 people in the community are under age 16. What's the unemployment rate? Now, remember, the unemployment rate is simply a mathematical equation where you take the number of unemployed divided by the labor force. Okay? Now, from the labor force, you should know that you always need to factor out people under the age of 16, people who are institutionalized. That includes people in prisons, people in mental institutions, people in even retirement homes, people who are not in a position of their own free will to work, as well as people not actively looking for work who are discouraged workers. Now, in this scenario, it gives you some extraneous information, but the key thing here is right here. It says the size of the labor force. So you already know the size of the labor force, right? The size of the labor force is 500. Now, if the size of the labor force is 500 and 400 people are fully gainfully employed, obviously we also know how many people are unemployed, don't we? 500 minus 400 is 100. So the mathematical formula we're going to need here is 100 divided by 500, right? Which is 0.2, right? Times 100, so the unemployment rate is 20%. That's how you calculate the unemployment rate, and there are going to be a couple of questions on the quiz that are like that. Let's do one more to make sure everybody's comfortable with that. Again, we have a similar scenario here, and I apologize for walking out of the camera periodically as I attempt to move the camera or the PowerPoint back and forth. Going to need some of these cool eraser things. Keep the board nice and neat. Once again, we have some information, and we do know, and in this one it says the size of the labor force in the community is 1,000. 850 are gainfully employed. 50 are over the age of 16, do not have a job, and are not looking for work. In addition, 80 people in the community are under the age of 16. Again, the other information is somewhat extraneous. You're given the labor force, it's 1,000. If 850 people are gainfully employed, you take 1,000 minus 850, that leaves 150 unemployed people, right? Out of a full labor force of 1,000. That should be, if I did the math in my head correctly, 0.15 times 100. The unemployment rate for this particular problem is 15%. Okay? And that's one of the things we talked about in week 4, is how you calculate the unemployment rate, and that is how you'll have to do it on the week 6 quiz, as well as on the final exam. Okay? So everybody should be pretty comfortable with that. Let's move on to a new type of problem. We discussed the concept of gross domestic product, right? And we're trying to figure out gross domestic product, as we know, is a measurement of how well the economy is doing. And in this scenario here, it says you're comparing GDP, right? You have GDP in year 1, which is 15 trillion. And you have GDP in year 2, so it says 2005, 2006, right? So if GDP went from 15 trillion to 16 trillion, is that good economic news? Well, maybe. We're not sure yet, because we always have to adjust nominal GDP for inflation to convert it to what is called real GDP. Okay? Now, in order to do that, here's all you have to do. Now, in the year 2005, since that's the base year, okay, it's the first year we're talking about, nominal GDP and real GDP in the base year will always be the same. Okay? So in relation to 2005, nominal GDP, because it gives you that number there, was 15 trillion. For this scenario, that is also real GDP. Because obviously, if we start in 2005, we don't have any previous information on inflation to judge it by, right? So that's our starting point. Now, one of the ways in which you can adjust for inflation, right? First, we got to figure out what the inflation rate is. It's always new minus old over old. It went from 103 is the new inflation rate, right, or index. It was 100 divided by 100. That's 3 over 100 or 3%. The inflation rate is 3%. Okay? Now, in order to calculate and convert nominal GDP into real GDP, here is all you have to do. You take the new figure for this year. Okay? So in 2006, nominal GDP was 16 trillion. You divide that by the following number. It will be 1 plus the rate of inflation. So if the rate of inflation was 3%, it would be 1.03. If you take 16 divided by 1.03, real GDP for the year 2006 was not 16 trillion, because that would have been super good news. I mean, it's still pretty good news, but it appears to me that GDP is actually $15.534 trillion. Is that what you guys got?
15.53.
15.534? Right, okay, so there we go. But that's only part of what the question asks. The question says, by what percentage did real GDP increase? Once again, when we do rates of increase, the formula for rate of increase is always the same. It is, once again, new minus old divided by old times 100 will give you the rate of increase. So, we have the new number now. The new number is 15.534, right? That's the real GDP. We subtract 15 trillion, because that's our original base year, right? So it's 15.534 minus 15 divided by 15. Whatever that number is, you multiply it by 100, and it does appear when I did this that you got that GDP rose by 3.56%. Is that what you got? It should be 15.534 minus 15 divided by 15 times 100. Did that come out to 3.56%?
Yes, it did.
That's all you have to do for that. Okay? Step one, you got to figure out the inflation rate, right? Then you have to convert nominal GDP into real GDP and do that. Okay? Now we have another one like that. And I'll give you guys a moment to start slowly working through this one on your own before I help you out with it. Okay? So we have some similar numbers here. And annoyingly, I'm going to erase this all so you can't see it and just kind of exchange the numbers. But the process is going to be exactly the same. It says, suppose nominal GDP in 2005 was 11 trillion. And in 2006, it was 13 trillion. That sounds like good news. The general price index in 2005 was 100, and in 2006 it was 104. I would like to know by what percent real GDP has increased between 2005 and 2006. So go ahead and take a moment. And let's work through step one. The first thing we need to do is figure out, I suppose, the rate of inflation, right? So if we went from 104 minus 100 divided by 100, that looks like it looks like 4%, right? Is that the inflation rate, 4%?
Correct.
Okay, so it's 4%. So to determine the rate of inflation, it's 1 plus the rate of inflation. So the inflation rate is 1.04. So the first thing we got to do is convert this 13 trillion into from nominal GDP into real GDP. So how do we do that? We simply take 13 trillion, we divide it by what?
1.04.
1.04. Expertly done, gentlemen. When you do that, it appears that real GDP is going to be what?
12.5.
12.5 trillion. Excellent. But again, that's only half of the problem here, right? So what's our next step?
Rate of inflation, yeah, or rate of increase?
Well, yeah, the rate of increase, and that's always new minus old divided by old times 100. So 12.5 minus what?
13.
No.
Oh, I'm sorry, 11.
Right. 12.5 minus 11 divided by
11.
11 times
Times 100.
times 100. Right. And so how much did real GDP increase in that year?
13.636.
That is exactly correct. 13.63%. That is exactly correct. So for you guys who are watching this video at home, that's what you should have come up with, 13.63%. And there will be a couple of problems on the week 3 exam that ask you to do this. You'll be given very similar data. Again, the first thing you do is find the rate of inflation. So it's 1 plus whatever the increase is. Then you adjust nominal GDP, turn it into real GDP. Then to calculate the rate, once again, always new minus old divided by old times 100 gives you the rate of increase. Everybody comfy with that one? Lincoln, did you get that? All right, good man. Let's move on to the next problem.
I have a question.
Okay, hold your questions to the end if at all possible. Because I got to get this whole video in first. So, okay. In this one, it says, and these are really easy. There will be a couple of these on the test, and a couple of these appear on the final exam as well. This may be hard to read because of the way the computer's set up, but I'll read it to you. The consumer price index was 198.3 in January of 2006 and 202.4 in January 2007. What's the rate of inflation? Any idea how you do that? Right, same formula we did before. It's simply new minus old divided by old times 100. So in order to do that, someone tell me the inflation rate.
202.4.
It's 202.4 minus 198.3, that's 4.1, divided by 198.3 times 100 should be approximately 2.07%. That's the inflation rate. Everybody get that? Okay, again, that formula saves us a lot in this particular class. Always new, whenever you're doing rates of increase, new minus old divided by old times 100. Okay, so if you calculated that correctly, completely without my help, try this next one. The first, in January 2007, you have a price index of 185.2, and then you have a new one of 190.7. All I need to know is what's the inflation rate. So take a moment, set up your equation. Very simple. New minus old divided by old times 100, and you should get approximately
3.985. 3.99. Round up.
Huh. Is that what I got?
198.3 minus 190.7
Right.
divided by 190.7 times by 100.
Should be approximately what?
3.985.
Is that what you got, Lincoln? That's not what I got.
I got 197.
Okay, we got all sorts of interesting answers here. Okay,
Maybe I
so we take, wait a minute, hold on. We take new 190.7 minus 185.2, right? So that should have been what?
I'm sorry.
Wait, which one are you doing? You doing 6?
You're doing 6, right? So you'll be 198.3 minus 190.7.
Yeah, that's what we got.
Oh, okay. Then
There's anyone, I told you these did not follow that exactly. These are different problems.
Oh, yeah,
That's why I read them, so if everybody was following along with me. So that would explain why I got a different number, because you were working with different ones. But according to the ones I've given you here, what should the rate of inflation have been?
$2.96, 2.97.
Yes, 2.97%. Okay, very good. That's exactly what we were looking for. Okay, so far so good. The next one's kind of a challenging one. This takes some explanation. So let me read it to everybody, and then we'll discuss it. The question here says, as the euro appreciates in value relative to the US dollar, what happens to the price of US goods in Europe? That's part one. Then what happens to the price of European goods in the US? There's another part. Why would a country like China, for example, choose to keep their currency relatively pegged to the US dollar? And by that we mean, as the dollar goes up and down, China manipulates its currency to be relatively equally up or down with the US dollar, which is what it means to peg your currency, okay? If the US dollar were to appreciate considerably against most currencies, what would be the effect on Chinese exports to countries other than the US? There's a lot of questions in here. So let's deal with them one at a time, shall we? Let's deal with the first part. As the euro appreciates in value relative to the US dollar, what happens to the price of US goods in Europe? So when a country's currency appreciates, it becomes more valuable versus the other country's currency we're comparing. So in this case, if the dollar appreciates, right, it would take fewer euros to buy a dollar, wouldn't it? Right? Because, okay, so if it takes fewer euros,
So the euro can buy more U.S. goods.
yes, the euro, it takes, but again, when you buy goods, right, we don't just exchange goods. In order to do that, we have to exchange money first, okay? An American company doesn't want euros, it wants dollars and vice versa. So if the euro appreciates in value, like it will take, again, you'll need less euros to buy a dollar, right? So what happens to the price about U.S. goods? Okay, what happens to the price of European goods in the United States? Are European goods more expensive or less expensive in the United States? Think carefully through that. And an easy example is, let's say,
Don't you mean backwards, Professor? It's the price of U.S. goods in Europe.
what happens to the price of, what's what the question says? Oh, I'm sorry, I skipped to the second part. What happens to the price of U.S. goods in Europe? That's the easier one. What happens to the price of U.S. goods in Europe?
They decline.
So they become cheaper, right? Yes, very good. Why? Why do they become cheaper?
Because the euro now is a higher amount than what the U.S. dollar is. So when we're exporting it, we're selling it to Europe at that dollar amount.
Excellent. Okay, very good. So we know that the price, what happens to the price of U.S. goods in Europe? So American goods will be cheaper, right? Okay, good. What happens to the price of European goods in the United States? That's going to be pretty easy, isn't it? If the price of U.S. goods in Europe becomes cheaper because of an increase in value of the euro, what happens to the reverse, the price of European goods in the United States?
So more expensive.
They become more expensive, right? Okay, very good. Now, the next part of the question says, why would a country like China keep their currency relatively pegged to the US dollar? I mean, there's a lot of things that go into that. The simplest explanation is that generally, the United States is a huge trading partner for China. So if both currencies are going all over the map, it makes trade difficult, doesn't it? Because the relative prices of goods consistently are changing, and that's not usually steady conditions are good for business. So if you're China and the US is your biggest trading partner, would you like, whatever the relative values are, would you like them to be relatively consistent? And the answer is yes. So a lot of times countries like China will certainly say, okay, if the dollar appreciates 2%, we'll appreciate the yuan 2%. If it decreases 1%, and that way the relative difference in our currencies remain the same. And that makes it much easier to engage in international trade. Okay? And that's how you do that. The next part of the question is a little trickier. If the US dollar were to appreciate considerably against most currencies, so once again, if the dollar is appreciating, how will that impact the effect of Chinese exports to countries other than the US? First, if China keeps its currency pegged to the US, right? If the US appreciates its currency, what happens to Chinese currency?
It also raises.
Right. So will there be any impact whatsoever?
Yes.
No, not between US and China.
Not between US.
Right, because, right, so between US and China first, there shouldn't be much of an issue because their currencies are fluctuating in relatively synchronous fashion, right?
Correct.
But what about Chinese goods? And the easy way to think about this is the same thing now that's going to happen to US goods being shipped, right, is going to happen to Chinese goods being shipped to other countries, right? So if the dollar appreciates in value, okay, what happens to the price of US goods in Europe? If the dollar, and we'll do the dollar first, if the dollar appreciates in value, which was the first part of the scenario, what will happen to the price of US goods in Europe?
They will increase.
They will increase, right. Now, since China is keeping its currency pegged to the United States, is the same thing going to happen to Chinese goods being exported to Europe?
Yes.
Absolutely, right? So Chinese exports to other countries, will they go up or will they go down?
Go up.
Well, the exports, not the price. Right, if the price of exports goes up, people will export less. So the total amount of exports would decrease. Everybody comfy with that? Wow, that's good, because that's one of the harder questions on the test, because there's so many different parts to it. But if you just break it down into small chunks and understand the relative strengths of what an increase in currency does to exports and imports in another country, you should be strong on that question. So very good, nicely done. Let's move on to the next one. Okay. Suppose the Canadian dollar price of 1 British pound is $2.12 Canadian. A hotel room in London costs 120 pounds, while a similar hotel room in Toronto costs 250 Canadian. In which city is the room cheaper? How would we figure that out?
You have to convert it.
Yeah, and here's what we know. The price, we know that 1 pound, right, 1 British pound is equal to what? What is a British pound equal to in Canadian dollars?
2.12.
Right, 2.12. So let's convert the London hotel. If the London hotel was 120 pounds, we would do what? We would multiply it by what? 2.12. So the hotel in Toronto, we know, is 250 Canadian. What is the hotel in London cost?
Divided by.
No, just multiply it. It's 120 pounds, and every pound get you this much in Canadian. Just multiply them out.
Yes, but then when you're looking at London, wouldn't you divide it by?
No, no. What's 120 times 212? 254.40 Canadian.
Oh, I'm jumping on.
Now we have a we've converted apples to apples and oranges to oranges here. So even though it's basically the same hotel room in different parts of the world, right? Because of the relative difference in currency value, the room is actually a little bit more expensive where? In London, right. Okay, very good. And there's a couple questions on the week 6 test that ask you to understand how currency conversion works. And all you really do is figure out the rate of exchange. And I hope that's still working. Good. Figure out the rate of exchange and then multiply it. So you convert, in essence, you had to convert everything into Canadian dollars. The Canadian one, the Toronto room's already done for us. But in order to find which one is relatively actually more expensive or least expensive, we have to compare apples to apples. Canadian dollars to Canadian dollars or British pounds to British pounds. Okay? That was pretty straightforward. The next one, however, is a teeny bit trickier. This deals with the concept of trade and comparative advantage. Now, when you calculate trade and comparative advantage, we're given a scenario here between two countries, and again, this is a really simple model, but it'll illustrate the point for us. We have two countries, Greece and Egypt, and we're going to assume there's no massive inflation in Greece at this point because that'll just throw up our analysis. So for the sake of arguments here, let's assume Greece and Egypt are producing two products. The question is, what would be feasible terms of trade? In order to determine terms of trade, one of the things we could probably do is chart this out on a production possibilities curve, but we don't need to do that. First thing we'll do is we will add up all of this stuff. We'll do shirts first, okay? And we'll deal with our friends, which one of the Greeks? This is Egypt first. So it looks like 3, 9, 18, 30 shirts, right? Pants is what is that, 120, right? Correct? 60, 90, yeah, 120. Correct?
Yeah.
Okay. Now, let's do the same for our friends, the Greeks. And the Greeks, it looks like 10, 20 shirts, right? And how many pairs of pants do those pesky Greeks make? 60? 60. Now, once you've done that, all you need to do is figure out, again, this represents a production possibilities curve. If you used all your resources, in this case, to produce pants, there was nothing left to make shirts, right? So you see that in each of the end states of this data set, right? So if those nice little Egyptian workers spent all their time and all their resources making pants, or shirts, I'm sorry, we'd have 12 really nice Egyptian cotton shirts. Sadly, we wouldn't have any pants. That'd be sad, wouldn't it? So in understanding terms of trade, okay, what you basically have to do is figure out the ratio here. So in this case, for the Egyptians, it's 120 pants for or 30 shirts for every 120 pair of pants, right? That is, they do 1 shirt for every 4 pants. It is a 1-to-4 ratio, right? Now, let's do the same thing with our friends, the Greeks. If they do 20 shirts, or I'm sorry, 60 pants for every 20 shirts, this appears to be a what? 1 shirt for how many pants? 1 shirt is equal to 3 pair of pants, or a 1-to-3 ratio. Okay? So given this data, the only feasible terms of trade between these two countries, when you determine the ratios, Okay? It must fall somewhere between this. So in this case, the answer is this. The only feasible terms of trade are anywhere between 3 and 4 pants per shirt. Because again, the upper limits here, because we make a lot more pants than we do shirts. So terms of trade between these two nations would be anywhere between 3 or 4 pants per shirt. That's how you develop terms of trade. See, if you don't do that, if indeed you have anything beyond that, any terms higher than that, one of the countries would be better off, would be able to do better in terms of trade simply by trading off their own resources. So in essence, if these were two production possibilities curve between pants and shirts, it'll look like that, and another one's going to look like this. What we're trying to figure out is what is a fair exchange between the two. And the way you do that is you calculate the ratio between the two goods internally first. And the favorable terms of trade are always between the upper limits. And in these cases, the upper limits are somewhere between 3 and 4 pants for every shirt. Those are equitable terms of trade. And again, so all you do for those, once again, add up your numbers first. Okay? Once the numbers are added up, determine your ratios. Now, in order for this to work, by the way, you do have to get the same initial ratio. If this was 2 pants to 3 shirts or something like that, the base number here has to be the same. If the base number here, in this case it's 1, is identical, then equitable terms of trade fall between the upper limits for both, anywhere between 3 and 4. Okay? That's how you'll solve that.
What if it's not? What if it's
Whether it's
2
three
to
or
4 and
top.
3 to 3?
Then you have extra calculations to do. Fortunately, on this particular, I'm pretty sure all the ones on the quiz will not make you do that. This is sometimes easier to look at graphically, but for this one, it's a really simple example. And basically what we're demonstrating here is that the law of comparative advantage basically means this. Not like, why do we import stuff in the United States? Why do we import goods?
Because we don't make them ourselves.
Well, it's not that we don't make them. We could, right? We could.
Or it could be made cheaper.
Yeah, that's the issue. There are some countries that are, for any number of reasons, better at doing things than other countries. We don't make a lot of coffee. We could produce coffee in the United States. But the problem is our geography is not well suited for it. So it'd be very expensive for us to make quality coffee. Whereas those nice little folks in Colombia, because of their geography and their climate, they're well suited. They do it well. So, but there's other things we do well. We make computer software and electronic stuff like that really well. They don't. The idea is if countries concentrate on things they have an advantage in, en masse, the world gets more goods. See, if Colombia had to make coffee and computers, and the United States had to make coffee and computers, we each do one well and one not as well. The total amount of computers and coffee in the world then would be less than if Colombia just made coffee because they're really good at it, and we just made computers because we're really good at it. So the net result of allowing nations to concentrate on what they have an advantage in produces worldwide more goods. Is more goods worldwide a good thing? Right, clearly the answer is yes. That's the essence of comparative advantage, and that's why people trade. There are things other people do more efficiently than you. And hopefully, fingers crossed, there might be some things that you do more efficiently than them. That's where the advantage of trade comes in. And that is the essence of why people have been trading goods since the beginning of time. Okay? So there will be one question like that one on the quiz. This is a nice easy one. Okay. It says here, the Republic of Republic, that's a great name, only produces two goods, fish and chips. Again, this is a real simple model, but it is going to illustrate what we're doing here. For those of you that can't read this, I'll read it to you. The Republic of Republic produces two goods and services, fish and chips. In 2006, okay, so let's start with 2006. 2006, 1,000 units of fish, right, were sold for $8 per unit, and 5,000 chips were sold at $1 per unit. Okay? So let's see if we can figure out, if that's all they produced, right? What is the nominal GDP of this country in 2006? It's 13,000, right? That is the nominal GDP. That's the total amount of goods and services produced in this country, right? That's nominal GDP. What is real GDP?
It's going to be 13,005. Or
what is real GDP in the base year? Always nominal GDP and real GDP in the base year are the same thing. There's no inflation to adjust for. This is the first year I'm looking at it. So in 2006, nominal GDP is 13,000, so is real GDP. Okay? But what the question wants to know is, we're going to take a look at 2007 because we had different things happen. Okay? There is a shortcut for calculating differences in GDP. When you do it, here's all you have to do. When calculating real GDP for a given year, write this down. You use the production numbers from the new year and the prices from the base year. So, if I wanted to know in 2007 what was real GDP, here's what I would do. Again, I used the new production figures because in 2007 I had 1,500 units of fish, okay? But I go back and use my original $8. I also had 6,000 chips sold, and I go back to my original number. Now, if you just did nominal GDP, you would do it like this. Here's the nominal first. You had 1,500 fish times how many dollars? 10 bucks, right? And you had how many chips sold? You had 6,000 chips, and they were sold at what in year two? $2. Nominal GDP in 2007 for this particular country was $27,000, right? But so that would look like, wow, what a big increase, right? But it's not that big. It's still an increase. But in order to figure out relative to prices in 2006, you go back to those prices and you multiply it out this way, and you would have gotten, in fact, do the math, 18,000. Real GDP in 2006 was $13,000. Real GDP in 2007 was $18,000. Nominal GDP was what in 2007? No. Nominal was 27,000. Nominal, you just multiply everything out. Okay? But what the difference is, we sold more, that's good. But if you'll notice, the prices went up in both of these years, right? Between them. So in order to figure out whether or not we were producing, because it's, are we producing more stuff? We're not calculating if we use the same price. What if inflation occurred here? We clearly have an increase in price. So all we do when we're talking about real GDP is we are comparing the amount of pure stuff, not factoring in inflation. So based in these old prices of 2006, did we produce more stuff? The answer is clearly yes. We produced 1,000 of these, now we're up to 1,500. We had 5,000 of these, now we have 6,000 of these. We clearly produced more stuff. That's good news. But we need to factor out the inflation. And one of the easy tricks to doing it is simply substituting the base year prices for the current year production. That instantly converts it back to the relative prices of the base year. And that's the easiest way to do this. Okay, only two more, and then we're pretty much finished with all this. And I think this one's pretty straightforward. Again, it's a very simple example. Country A. I don't like country A. That's a dumb name. Let's go with current land, because that's a nice name for a country. So let's assume in current land, and I'd like to be the king of current land, but apparently we only make two things in current land. We make elephants and saddles. I have no idea why. In 2006, and I think you already know how to do this, right? In 2006, we produced 30 elephants, which sold for $3,000 per unit, and 50 saddles at $300 per unit. Now, can anyone calculate nominal GDP for the year 2006? Nominal GDP for 2006, how would we do that? We will simply take product one, which is elephants, 30 times 3,000, which is what? 9,000, right? And then 50 times 300, which is what? 15,000, right? So what is nominal GDP in this year? Is it 24,000? 24,000. What's real GDP in this year?
Same.
Right, very good. It's the same, because it's always real, nominal and real are always the same in the base year. Now, it says though in 2007 we've got some changes. We produced 40 units of elephants, which we now sold for 4,000, and 60 units of saddles that we sold for 250. So the price actually went down on that one. What is real GDP for 2007? What should you do? We just did this problem with fish and chips. What should you do to calculate?
Substitute the price in 2007. Oh, 2006 to 2007.
Not the price. We're going to use the old price.
Yes.
With the new production figures.
Yes. Yes.
So we are going to take 40 for the elephants times what?
40 times
3,000.
3,000, which is how much?
120. Yeah. No.
40 times 3,000 is?
Yeah. 100. It's 12,000.
12,000, right? Is it 12,000?
Yeah. It's 12.
Okay, it's 12,000. Then,
wait, 40 times 3,000?
yeah.
I think it's
Oh,
120,000.
Yeah, that's what I was originally saying.
Okay, I'm sorry, 120,000. And then we are going to take 60 saddles times what, though?
300.
Times 300. And what is 60 times 300?
18,000.
So what is real GDP for 2007?
138,000.
138,000. It's just like the fish and chips one we did. You substitute the new production figures for the year you're trying to figure out. but you keep the dollar amounts, the prices from your base year. Again, that automatically figures in and calculates the inflation for you, or the deflation, whatever it may be for you, okay? Now here's the last problem on the test. It says a Honda Accord sells for $28,000 in the United States and 35,520 Swiss francs in Switzerland. Given an exchange rate of 1.25 Swiss francs equals $1. How do the car prices of both countries compare? And here's how you do that. So, if $1 is equal to 1.25 Swiss francs, right?
So we're gonna take 28,000 times by 1.25.
Right. 28,000 times what?
1.25.
Right. So precisely, what does the car cost in Swiss francs?
35,000.
35,000 Swiss francs, right? That was pretty easy, right? Those are all the, well, not all, but those are samples of all the types of problems you get on the week 6 quiz. Now again, your numbers may vary, but the types of problems are identical. The quiz is 11 questions. We just went through 11 questions. So if your numbers may be slightly different, but in essence, that's what you need to be able to do for the quiz. So any questions on that? Everybody's comfy with that? Good, then I can stop the recording right now, which will make me happy. And I think I know how